Let's look at another example of a quadratic function graph and all the little pieces that we need to talk about. This one is g of x equals negative x squared minus 2x minus 8. So this graph, we can tell that it opens down because the value of a is negative 1. And in fact, we already know, since a is negative 1, that the pattern for growing this parabola will be over 1, down 1, over 2, down 4, over 3, down 9. So we can use that when we start to graph. Second, let's look at our axis of symmetry, or line of symmetry. The line of symmetry is x equals opposite b over 2a. So in this case, opposite b is positive 2 over 2a, 2 times negative 1. So that's 2 over negative 2. So the axis of symmetry will be x equals negative 1. And we can use that to find our vertex. The vertex will go through negative 1, comma, and we're going to plug negative 1 in for x to figure out our y value. So y will be negative, or the opposite of, negative 1 squared minus 2 times negative 1 minus 8. We have to be really careful with the order of operations. We're going to square the negative 1 first, so that will be positive 1. Make it the opposite value. So it will be negative 1, and then we have negative 2 times negative 1 makes plus 2, and then minus 8. So the x value of that vertex, we have negative 1 plus 2 is 1, and then minus 8 is negative 7. So negative 1, negative 7. The y-intercept and x-intercepts will be next. The y-intercept is at 0, c, so that will be at 0, negative 8 for this problem. And then the x-intercepts we will set the equation equal to 0, so 0 equals negative x squared minus 2x minus 8. And we need to solve for x. Now the other two examples we've done so far, we've factored and completed the square. So let's try quadratic formula on this one. So we have x equals the opposite of b, so positive 2 plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a, which is negative 1, times c, which is negative 8, and then divided by 2 times a, which is negative 1. So we get x equals 2 plus or minus the square root of, 4, and then we've got negative 4 times negative 1 is positive 4, times negative 8 is negative 32. So that's really 4 minus 32 in the discriminant, which is negative 28. So we have negative 28 in the radical, all over negative 2. And we need to simplify that square root of negative 28, so x will equal, 28 breaks down into 4 times 7, and the 4 breaks into 2 times 2, so 2 times 2 times 7. And we have that negative out in front, so that makes it become an I. So the 2's come out, the 7 stays in, so I have 2 plus or minus 2i square root of 7 all over negative 2. Now remember, we want to simplify this if we can. Since we have 2's in all 3 spaces here, we can divide them all. So x will equal, well, 2 divided by negative 2 is negative 1. And then when you have a plus or minus, if I divide the positive 1 by negative 2, I'll get the negative 1. If I divide the negative 2 by negative 2, I'll get the positive 1. So it still remains plus or minus, and I have I times the square root of 7. So my two x-intercepts will be negative 1 plus I square root of 7, 0, and negative 1 minus I squared root of 7, comma 0. But one thing that is important to notice, well, we've never graphed with imaginary numbers before, and there's a good reason for that. These are not on the real number plane, so these two x-intercepts are not going to be on the graph. When you get imaginary numbers for your x-intercepts, that means your parabola does not cross the x-axis. So that's kind of good to know. Let's kind of graph what we've got that we can get on our graph. We have our vertex at negative 1, negative 7. So negative 1 and then negative 7. 1, 2, 3, 4, 5, 6, 7. We have our y-intercept at 0, negative 8. We have no x-intercepts, but we do have our pattern for graphing. So from the vertex, we'll go over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4. So we at least can get a picture of what our graph is going to look like. And then we can use that picture to answer some questions. See, I'm going to label this negative 1 here. Okay. Let's talk about where this graph, what its domain and range are, where it's increasing and decreasing, and where it's positive and negative. So let's start with domain and range. The domain for any parabola is negative infinity to infinity. So we can answer that question really without even graphing. Then the range, we want to look at the y values. Starting at negative infinity, the range goes up to this spot right here and stops. There's no more graph after that. This value is the negative 7 from our vertex. So the range goes from negative infinity to negative 7 and then stops. Now where is this graph increasing and decreasing? Those values are given by going from negative infinity out to the left to over to positive infinity at the right. So if I start at negative infinity, what's my graph doing? Is it increasing or going uphill, or is it decreasing or going downhill? As I go left to right, imagine if you were walking along this graph, you would be going up a very steep hill until you get to this spot right here, which is the x value at negative 1. So it's increasing from negative infinity up until negative 1. So we have increasing from negative infinity to negative 1. And then at that x value of negative 1, if I keep walking along the graph to the right, it's going downhill. So we're increasing negative infinity to negative 1 and then decreasing negative 1 to infinity. So decreasing negative 1 to infinity. Then positive and negative. Positive means the graph is above the x-axis. Negative means the graph is below the x-axis. So if you look at the x-axis, if I'm just looking above the x-axis at where the graph is positive, you can see that it's not ever above the x-axis. So it is positive nowhere. And where is it below the x-axis as I go left to right? Well, it's negative from negative infinity all the way to infinity. So from negative infinity to infinity. That just means for all real numbers or everywhere, it's negative. Does this graph have a maximum value or a minimum value? This graph has a maximum because it starts from down low, it comes up to a certain point, and then it turns around and starts heading back down. It has a maximum, and the maximum value is the highest y value that the graph ever gets to, and the highest y value happens to be negative 7. So the maximum value is negative 7.